Hello viewers, in today's class we are going to discuss an important inequality which will be proved using Lagrange's mean value theorem, right? So let us start. Now here we have to prove that log of 1 plus x is less than x plus x square for all x greater than 0, right? So here we shall prove this inequality using the mean value theorem, right? So for mean value theorem, what we do, let us first assume an appropriate function, right? So here we'll assume the function f of x is equal to log of 1 plus x minus x square, right? And we define this function for all x greater than 0, and here we'll take an interval that is 0 to x, right? So here what we will do, we'll first try to satisfy the conditions of Lagrange's mean value theorem, right? So now Lagrange's mean value theorem says that if we have a function, say y is equal to f of x defined in some domain D where we have an interval a comma b, right? So this interval is a subset of this domain D, and if this function f of x is continuous in the interval a comma b, and this function f of x is differentiable in the interval a comma b, then there must exist one point, say x is equal to c, which lies in the interval a comma b, or we can write c is greater than a but less than b, such that f prime of c is the derivative of f at this point x is equal to c, and f prime of c must be equal to f of b minus f of a divided by b minus a, right? So this is the statement of Lagrange's mean value theorem, right? So here we have the function f of x is equal to log of 1 plus x minus x square, right? So here what we will do, we'll try to satisfy the conditions of Lagrange's mean value theorem in the interval 0 comma x, right? So here a is 0. If we compare this interval with this one, then we have a is 0 and b is equal to x, right? So here the first condition is that f of x should be continuous in the interval 0 comma x, right? Now see, here f of x is a combination of two continuous functions, right? So log of 1 plus x is obviously a continuous function in its domain where x is greater than 0. So log of 1 plus x must be a continuous function in the interval 0 comma x, right? And similarly here we have the quadratic function or the polynomial function. So we know that a polynomial function is a continuous function in its domain. So here x square is also a continuous function in the interval 0 comma x, right? And fx is a combination of a log function and the polynomial function, right? So we can write f of x as log of 1 plus x plus minus x square. So this is the sum of two continuous functions, right? This is continuous and this is also continuous, right? So we know that if a function is expressed in terms of as a sum of two continuous functions, then the function f of x must be a continuous function in the interval 0 comma x, right? Okay, so now we have shown that this function is a continuous function. Now let us find out the derivative of f of x, right? So the derivative of f of x is f prime of x. So we have d by dx of log of 1 plus x, and here we have d by dx of x square. So we have 1 over 1 plus x, because the derivative of log x is 1 over x. So here we have 1 over 1 plus x, so this is 1 over 1 plus x, and here we have 2x, right? So we can easily see that this function f of x has a derivative at each point in the interval 0 comma x, right, where x is obviously greater than 0, which is given in the problem, right? So this function f of x is differentiable in the interval 0 comma x, right? So from Lagrange's mean value theorem, there must exist one point, say C, which lies between 0 and x, right? So C must lie between 0 and x, such that f prime of C must be equal to f of b minus f of a divided by b minus a. Here b is x, a is 0, so we can write f of x minus f of 0 divided by x minus 0, right? So f prime of c can be written from this expression by taking x is equal to c. So we have 1 over 1 plus c minus 2c, right? Here we have 2x. So now here we have f of x. F of x is a log of 1 plus x minus x square, and f of 0 can be obtained by taking x is equal to 0 in this function. So f of 0 is log of 1 plus 0 minus 0 square. So we have log of 1 minus 0. Log of 1 is 0, so we have 0. So f of 0 is 0, so we can omit here 0. So now we are left with log of 1 plus x minus x square over x, right? So now we will utilize this expression to arrive at this inequality, right? So now what we will do further, see here we have c is obviously greater than 0, right? See here this point x is equal to c, it lies between 0 and x. So c is greater than 0, so 1 plus c must be greater than 1, right? So if we add 1 both sides, then we'll get 1 plus c must be greater than 1, right? So now if we take the reciprocal of both sides, so what we will get? We'll get 1 over 1 plus c must be less than 1, right? So when we take the reciprocal of both sides, the direction of the inequality get reversed, right? Okay, so now what we will do further, here we have minus 2c, right? So we'll subtract 2c in both sides, right? So we have 1 over 1 plus c minus 2c is less than 1 minus 2c, right? So here we have the inequality number 2, right? Okay, now see we have c is greater than 0, right? So if we multiply both sides by minus 2, then what we will get? We'll get minus 2c is less than 0, right? So now what we are doing, we are again taking this inequality, that is c is greater than 0. So when c is greater than 0, we multiply both sides by minus 2. So what we will get? Minus 2c is less than 0, because we are multiplying with a negative number, so the direction of the inequality get reversed, right? And now we'll add both sides 1. So we have 1 minus 2c is less than 0 plus 1, that is 1, right? So now 1 minus 2c is less than 1. So now if we combine inequality number 2 and 3, then from 2 and 3 we'll get 1 over 1 plus c minus 2c is less than 1 minus 2c, and this is further less than 1, right? And now if we take this expression and this one, then we have 1 over 1 plus c minus 2c is less than 1, right? So this is an important inequality here, right? Now 1 over 1 plus c minus 2c is equal to log of 1 plus x minus x square over x. So we can substitute it here. So we have a log of 1 plus x minus x square over x should be less than 1, right? Okay, now see, x is greater than 0. See, x is greater than 0, so we can safely multiply both sides of this inequality by x, right? So that we can get rid of this x. So now we have a log of 1 plus x minus x square is less than x, right? So x times 1 is x. Now taking this minus x square to this side, we have log of 1 plus x is less than x plus x square, right? And this is our desired inequality, right? So we have proved that log of 1 plus x is less than x plus x square for all x greater than 0, right? So viewers, this is how, by making use of Lagrange's mean value theorem, we can prove this inequality.